All right, students, this is Miss Whitaker. I'm doing my lesson today. Sorry about not having a lesson yesterday. Today we were learning about classifying numbers. So I'm going to kind of go back to what we did a little bit in class today. And this was a practice sheet that we kind of did after we watched a video. I will write the website down to go watch the video again if you need to. Today we did number classification. And we kind of refer to it back like as a hierarchy. So we usually start with natural numbers, which natural numbers are all numbers, all whole numbers that are positive and they cannot be zero. So zero cannot be included with the natural numbers, okay? Now, a whole number is any whole number that's positive including zero. Integers are all whole numbers that are positive or negative, and rational numbers are all numbers, positive or negative, and they include decimals and fractions. So, when we talked about hierarchy today, we talked about you can always move up the hierarchy, but you can never move down. So on your prep work tonight, the first few questions on the practice, they give you numbers, and you have to write what sets of numbers would it fall under. And when they mean sets, they mean you have to list, is it a whole number? Is it an integer number? Is it rational? Is it all three of those? And you don't have to write them all out, but you can just write the first initial if you'd like to. So if I look at the first number, which is negative 19. Negative 19 is a whole number, but it is a negative number. So since it's negative, he will not fall under the natural. He will not fall under the whole. He would fall under integers because he is negative and not positive. But remember, we move up the hierarchy. So if he's an integer, he's also a rational number. So we can move up, we just can't move down, okay? I'm going to erase this so I can do my second one. My second one that we practiced in class today was 1.2 repeated, okay? 1.2 repeated is not a whole number. It does have a whole number included, but he has to be equal to exact whole number to be a natural number. He's not. He's actually 1 and then 2/10 more. That repeated sign after means that it would keep repeating that 2, and it would go like this, okay? But if it has a repeated sign, he is a rational number, okay? So it would be 1.2 with a line over it. Now, he was not an integer because he was not a whole number, and he was not a negative whole number. He was not a whole number because he was not a whole number that was positive, and he's not a natural number because he was not a whole number that's positive that includes zero. Now, let's look at zero. Zero. I'm going to erase this. Zero, the next number, zero is a whole number, but remember, natural numbers cannot be zero. So I cannot start in the natural division. I'm at the start in the whole division. So remember what I said, you move up. If he's a whole number, he's also an integer. If he's an integer, he's also a rational number. Okay? So it's kind of like an umbrella. Okay? So rational is like the top of the umbrella, so that includes like a lot of numbers. It includes almost all numbers, okay? Let's look at number 3. Number 3 says 3. Not number 3. The number 3 is 3. So is he a natural number? Yes, he's natural because he's not 0 and he's whole. He is a whole number because he is positive and he's whole. He's an integer because remember, integers can be positive whole numbers and negative whole numbers. And he's rational because rationals include all numbers, including fractions and decimals. So remember, once you have it at the bottom, you just move it up. Move it up. Let's look at the next number, square root of square root of 10. Square root of 10. Square root of 10, if you punch this in the calculator, it's going to give you a decimal. It's going to go on forever and ever and ever. That's what these dots mean. It's going to go forever and ever and ever. So if it's a number that goes on forever and ever, ever to infinity, he is now irrational. That's how you become irrational, if it goes on forever and ever, ever. Now, you might look at the next number, the square root of 81, and you might say, oh, he's a square root. He's going to go on forever and ever and ever. That's not true, because he's a perfect square root. And a perfect square root would be a number that its factors are the same exact numbers that equal it. So what are two factors that equal 81 that are the exact numbers? That would be 9 times 9. So the square root of 81 is 9. So since it equals a whole number, then he actually gets to start at the natural number, because he is a whole number that's greater than 0. So that square root of 81 goes here. And if he's at the natural number, he's also a whole number. If he's a whole number, he's also an integer. If he's an integer, he's also a rational number. So remember, if you're at the bottom, you can move straight up. You just can't go down, okay? Some other square root numbers that equal a whole number would be the square root. We kind of talked about this in class on the board. Square root of 4 is a perfect square root, because what equals it is 2 times 2, which, remember, those are two factors that are the same. So the square root of 4 is 2. Another perfect square root would be 9, because what equals 9? 3 times 3. So the square root of 9 would be 3. Another perfect square root would be 16, because what equals 16? 4 times 4. Again, they're two factors that are the same. So the square root of 16 would be 4. And the next one would be the square root of 25. And then we have the square root of 36, square root of 49, square root of 64, square root of 81, and so on. So remember, 10 is not a perfect square root, because there's no two factors that equal it that are exactly the same. The only thing that equals 10 is 1 times 10 and 2 times 5, and those are not the same numbers. So now that we talked about that, let's get back on track and go where we left off. We left off with the next one is a decimal, 3.456. Now, that decimal does eventually stop. Yes, he has a whole number, but he's not just exactly a whole number. He's a whole number plus more. So he's not able to go into the natural. He's not able to go into the whole category. He's not able to go into the integer category. He has to be a rational number. Okay? And then another example that we can look at would be negative 6/11. Yes, he is negative, but he is not a whole number. So he's got to go straight over here to rational. This is another example right here that those dots means it goes on forever and ever and ever to infinity. So he's going to be irrational. Pi, anything with pi means it goes on forever and ever and ever. So it's going to also be irrational. Now, negative 44. He is a whole number, but he's not a positive whole number. Again, he would not be whole because he's not positive. But he would be an integer because he is a whole number. And if you're negative, you have to start in the integer spot. Then you can move up. Okay? So hopefully this helps you a little bit, remind you about, the different classifications of numbers. Again, remember, naturals are all whole numbers. All whole numbers except 0. Whole numbers are all positive whole numbers, including 0. I should have said down here, all positive whole numbers except 0. Whole numbers are all positive numbers, including 0. Integers are all whole numbers, including 0, and negative numbers. And rational numbers are all of these. Rational numbers are 0, its whole numbers, its whole negative numbers, and its fractions and decimals. So those are all rational numbers. But if it's a decimal or a fraction, it has to come to a stop. It can't go on forever and ever and ever. So I hope this helps you for tonight. Your homework tonight looks like this. So this is the part I was talking about on the practice. On this part, you want to make sure you might want to write your hierarchy down up for like a key. I would write natural numbers, then we have whole numbers, then we have integers, and then we have rational numbers. So remember, you have to move up the hierarchy. So if I give you 1/5, is he a natural whole number? No. Is he a whole number? No. Is he an integer? No. He's just a rational number. So I just would put next to him R. Okay. The second one is -18 degrees. Is he a natural number? No, because he's not positive. Is he a whole number? No, because he's not positive. Is he an integer? Yes, because he's a whole number, but he can be negative. So I would put I for integer, and then if he's an integer, he's also a rational. So that's how you're supposed to answer problems 1A through E. 2A, B, and C, all they want you to do here is to plot the numbers. Remember, a plot is a dot at the location. And then they ask you to plot all 3 numbers, including they want you to put a number that would fall in between. What would fall in between those 2 numbers? Well, you could pick a lot of numbers. I would pick 9 maybe. -9 would fall in between. Okay, so you can plot it. You're supposed to do B and C the same. And then the back is review, which the review is review. So you should be able to do all of that. Number 3 at the bottom, when they ask you to plot the order pairs, you're going to make just a coordinate like this, a coordinate plane, and you're going to put 0 here, 1, 2, 3, 4, 5, 6, and you're going to do the same thing on the y-axis. And then you're going to plot. Where would I find 2, 4? That means you go over to the 2 and up to the 4. This is from 5th grade. Go over to the 2, up to the floor, and plot it. I might put an A there. Okay, so you got to do the rest of the B and C. Hope you have a good night. I hope this helps you. Oh, real quick, the website to go to Khan Academy is... it looks like this. So it's right up here at the top. Okay, if you type in probably up to this line where it says operations, it'll bring you to where you need to go. Or if you just go to Khan Academy and you put in classifying numbers, that will help you watch the video if you would like to tonight. Have a good night. Good luck on your homework.